Yes. Hi, everyone. So I have a lot of pressure because I present right after two very interesting invited talks, but thank you for staying. So we'll be talking in this presentation about attribution modeling in display advertising, and more specifically, how we can use a model of the attribution for doing a better bidding strategy. So this is the outline of the talk. I will do a small recap of the ecosystem of the real-time bidding in display advertising. And then I will present the model, so a simple attribution model and how we turn it into an attribution-aware bidder. You understood that this is really important. I will give a word on the impact of the offline metrics. And finally conclude by some experiments and the results. So let me start with a small recap on performance display advertising. So we had quite a lot of talks on this topic today, but so the main idea is that the user browses web pages on publisher website, and this triggers a set of real-time auctions for buying ads on this web page. And as Criteo, basically we help the advertisers to buy ads on the slot. So the feedback model is quite simple. The user buys something on the advertiser website. In that case, Criteo would get some reward from the advertiser, and the publisher gets paid by us on a CPM basis. So the ecosystem is quite simple. Now let's look at the baseline, very simple bidding strategy. So I consider the simple hypothesis that all the auctions are second price. So the dominant strategy in that case is simply to bid the expected value. So again, we had quite a lot of presentation on this today. So that means we would like to bid something proportional to the value of the conversions times the probability of sale. So in this work, I only consider conversion-based performance attribution. So this P sale here actually is the probability of what we tend to call post-click attributed conversions. So of course, the attribution of the advertiser plays a very important role here. So let's have a look at this advertiser attribution procedure. So the attribution process is basically when there is an online conversion, the advertiser will give credit to all the previous touch points before the conversion. And the industry standard attribution model is still the last click attribution. That means that only the last click gets credit for the attribution. So things are moving nowadays. So this last click model clearly is not causal at all, and it's clearly not the best one, but still widely used. In the remaining of the talk, I will consider that we use this last click advertiser attribution, but it's not a strong hypothesis that we make. We can relax it. So now, basically, we ask ourselves one simple question in this talk. So what would be the optimal bidding strategy right after a click? Is the baseline bidding policy still the optimal one or not? So let me take the attribution from the other perspective. So now I don't see the attribution from the advertiser's perspective, I see it from Criteo's perspective. Okay? So this is one simple timeline that we observe in our logs. So there is a conversion at the end here, and in our logs we observe three different clicks before that conversion. Okay? So before the first click, Criteo has zero probability of getting an attribution for this conversion, because the click is usually a strong signal for attribution. And then when there is the first click, if the advertiser is working on last click, then the probability that we get the attribution immediately will be 1. And then when the time passes, this probability decreases, because the competition might get another click, and in general, when the time passes after a click, the chances that this particular click actually generated the sale is very low. So there is this really time-dependent attribution probability on our side. And basically, we would like to leverage this phenomenon in our bidding strategy. So without entering into detail, so basically we model this decrease in attribution probability as a simple exponential decay according to the time after the click. So it's a very simple model. We absolutely don't claim that this is the best attribution model that we can provide, but what we are interested in is how can we use such a simple model for building a better bidding strategy. So let's go back to our baseline bidding strategy, which is to bid CPA and P-sale. So in that setup, basically how the baseline bidding policy uses the information of the advertiser attribution that is last click. So basically it has something to do with the positives and negative labels that we use in our binary model. Okay? So as a very simple picture, we have 3 clicks on the logs. The baseline bidding policy would consider that only the last click generated the sale. So we kind of mimic the external attribution the attribution scheme internally. So you can see it as an internal attribution problem if you want. But we could also do something very different internally. Even if the advertiser is doing last click, we could challenge the internal attribution as well. And the model that I presented before using the exponential decay would do something like 0.6, 0.1, and 0.3. Yeah.
What's your logic about the last approach, which is exponential delay?
What's the sorry?
What's your logic about using this exponential delay? Why you use that? How do you convince yourself the first touch is?
I will come to it now. This is exactly what I want to explain here. So basically, why do we want to use this exponential decay after a click? So basically, consider this simple timeline here. There is a click here, and what is doing the baseline bidding strategy? Usually, the click is already a very strong user engagement signal. So a bidder in that case will tend to increase the bid value right after a click, because this bidder does not want to lose the last click. So he wants to bid again until getting the last click for that sale. But what we think is that we should do the opposite. We should only bid the marginal value that brings a new display. So what we propose is to do exactly the opposite. So by using this exponential decay, basically we will bid almost 0 right after a click, which is kind of counterintuitive. But if we bid 0 right after a click, we still get some probability of getting the attribution thanks to the previous click. So we don't need to spend a lot of money and kind of increase the exposure for the user after a click, because we already have some probability of getting the attribution. So basically, that's why we turn our attribution model based on the exponential decay into this new attribution over bidder. So using the labels that I shown here, so ALC represent the last click labels, then you can see that the baseline bidder bids the probability of proportional to the probability of last click attribution given X. And what we propose to do is bidding proportionally to the probability of having a click leading to a conversion without doing any internal attribution at this step, but then modulating this probability by the exponential decay that I've shown before. So this will produce exactly what I explained here. Right after a click, we will basically drastically decrease the bid values. Now let's have a look at what's the impact of this change in the bidding policy on the offline metrics. So this morning, Damien talked about the utility metric that is usually used for evaluating different bidders. So it's a very simple empirical estimation of the payoffs that we observe on these theoretical logs. We can make it more robust by adding some uncertainty on the cost distribution. Damien also presented this morning. But there is an explicit mention here of the internal attribution procedure. This AI represents is this particular display a last click display before conversion. And of course, if we use directly this utility on our bidder, it will not work properly. So what we propose also in the paper is to extend the utility by extending the attribution procedure here. So here, in this attribution over expected utility, basically you can plug any attribution scheme that you want, and you would obtain a new metric. So properly evaluating this metric is not part of the paper, that we will need a full correlation analysis offline, online, but it might be something that we can do in the future. So now let's see what happens on data. So this is, for example, the decay of attribution rate that we observe in the logs plotted with respect to time after a click. So if that's what I explained before. So right after a click, the probability of getting attribution is almost 1. And when time passes, the probability decreases, which is kind of logical. And that's also kind of represent the exponential decay that we have modeled. Now also, as I mentioned before, when we only have 1 click in our logs before conversion, our model will not differ a lot from the baseline bidder. But what we observe in the logs is that more than 40% of the conversions have more than 1 click in the logs. So in the end, the two bidders are very, very different. Now let's do some offline evaluation on the data set. So we generated a data set that we logged from Criteo traffic. It has been anonymized. On each line, we have an impression with a lot of things that we can you can use, for example, to compute utilities. And you also have the attribution label. That means if the conversion was attributed to Criteo or not. Here you have some information. This dataset will be available publicly soon. If you want to play with some attribution data, feel free to check this, and we'll be happy if you can just play with this dataset. So now, what are the results? So let's start with simple bid profiles, because it was like the main intuition of this paper was to decrease the bid after a click instead of increasing it like the standard bidding policy. So here on the right-hand side, you see that it's exactly what's happening. This curve here represents the last click bids after a click. So you see that we tend to increase a lot the bid values right after a click, and then it decreases slowly. So here it's only 1 day of data, but then it decreases slowly until up to 30 days if needed. And our bidding policy is here, and you see that it drastically decreases after a click and then increases shortly. All the models are learned using classical regularized logistic regression, and we use the hashing trick for projecting the data. This is standard. Now let's have a look at the results using the attribution over expected utility. So you see that our attribution bidder is clearly much better than the last click bidder. On the paper, we have more detailed results on also the variance using the last click expected utility with interesting results, but I will not enter into the details right now. So basically, what we are doing using this bidder is to limit the user overexposure after a click. So we think it's quite important for the user not to attack them a lot after clicks. We bid something that is closer to the incremental parts of what an ad should bring to the user. So it's also, we think, going in the right direction. And of course, as we decrease the bid values after a click, we gain some budgets that we can reinvest on more profitable campaigns, on more incremental ads. Because yeah, in the end, you know, right after the clicks, all the money that you spend is not really incremental. So it's probably much better to put this money on more incremental users. No, this doesn't work. So this was for offline evaluation, and of course we also did like a large-scale A/B test to kind of assess that this performance was correct. So we tested a very slightly different model, but which gets the similar idea of decreasing the bid after a click. And the actual results, while quite positive, we obtained like plus 5.5% of increase in our long-term metric online, which is quite a lot. And of course, one of the important aspects of this is that we improve the long-term metric for Criteo, we improve the ROI for the advertiser, and we lower the user exposure, which is also very important. So everyone is winning using this strategy. Of course, there are lots of different areas of possible future research. The model for the attribution that we propose is very simplistic, and we don't claim that is the best model, but it's more like for explaining the principle of what you can do with it, but we can do much better attribution modeling. There is a link also on, the conversions are delayed. So right after the click, we might still not observe some of the conversion that might happen later. And we should also take this into account. And I guess it was addressed by one of the paper before. So there's still quite a lot of work to be done in that area. The metric that we use is biased. It's low variance, but highly biased. We have observed in practice that the attribution-aware metric that we see is more correlated to the online results, but still there are lots of work to be done in building a robust counterfactual offline metric in this kind of topics. And yeah, thanks very much for your attention.